Hello and welcome to today's installment of the Introspect Technology I3C video series. Today we'll continue on sideband bus testing, and we will show how to perform complete characterization of sideband bus components on a JEDEC DDR5 DIMM. We'll show how to select the devices that we're testing and then create an automation test suite based on the Python programming language to allow you to characterize a device within only a few minutes. So we have previously created a test procedure for this demo, and that consisted of a set of functions that have each been written for the specific test that we're trying to perform, including characterization tests like frequency tests. And so we have written these functions and then created the test suite API where a user can just select whether they want to run a certain test or not. And this is all done in Python. And if we simply run the test right now, it will go through every possible test that's been pre-programmed, and then it will decide whether to run it or not based on the user input. So here it's going through the tests, and we'll see things like reading all the MR registers in the SPD. These are all the ones that we just saw scrolling by here. Then we'll see the read registers on the PMIX again, all automatically, and they're all running very rapidly in the background. Here we're doing some write testing now, where we would write into a register and check that the write operation has been done properly. So here we've written into MR26 and make sure that it's correct. And then we will get into the PMIC and do the same thing as well. So you can see that just the Python language allows us for complete automation, where you can just develop library after library of tests, including characterization tests like this frequency testing function here, where we're varying the open drain frequency and then the push-pull frequency as well. So in the code for frequency test, we would be essentially modifying the properties of the sideband bus controller, and that's done through the master params component that is shown here at the top left. So this master parameters component will have properties for open drain frequency and for push-pull frequency, as well as for I2C legacy frequency as well, and many other timing parameters as well. So this function, the SCL frequency test, is programmatically changing these properties on the fly, and then every time it changes them, it goes and performs an operation on the DIMM to make sure that everything is okay. And so here, some open drain frequencies on the PMIC device behind the SPD have shown some errors, as we can see here. And so that's the value of this tool. We're finding that the input side of the SPD is working at full frequency, but the local side of the SPD is not necessarily working at full frequency. And this would allow for further debugging that can happen on the device under test. So the test is now finished. It gives us actually a notes folder where we can see a summary of the test results that were performed. And it also gives us individual captures, of course, for each test. So for example, the MR read register tests were all done in this kind of data log. And we're showing here that each test basically can have its own protocol analyzer trace. And where there are errors, we will see error messages as highlighted here in the GUI. But again, the protocol analyzer is indispensable really for looking for defects or looking for faults in the design and helping solve them. Thank you so much for watching. We hope that this has been useful, and please come back again to see further videos about the Introspect Technology SV4E I3C test and debug module.